This is lesson 3.4, which was solving for x and y intercepts. And so just a quick review of yesterday's lesson to make sure that we're all on the same page. How do we graph using slope-intercept form? Slope-intercept form is y equals mx plus b. That is slope-intercept form, and so we use this to graph lines. So explaining in steps how to graph y equals 2x minus 5. First, I will identify the slope as 2 over 1. The slope is right here. That's our slope. And the y-intercept as 0, negative 5. This is our y-intercept. Okay, so I've identified that stuff. So now, then I will graph the y-intercept. Okay, so the y-intercept is 0, 5. So right or left 0, up or down 5. It's my y-intercept. Next, I will count the slope, which is a rise of 2 and then a run of 1. So from here, from the y-intercept, rise of 2, run of 1. I'm going to do that a couple times just to make sure that I have a solid line. And I'm drawing the arrows because it helps me. Lastly, I'll draw the line of solutions to represent all solutions. What I have graphed here is just, what is that, like 6? I've graphed 6 solutions to the equation. However, there's a lot more than 6, right? These 6 are not the only ones. There's all of these over here, all of these over here, and everything in between. So we do that. We draw the line to represent all solutions. Okay. But today's objective is actually graphing using x and y intercepts. And so these points, these all intersect the y-axis. So these would all be y-intercepts. Let's see what they have in common. This point is 0, 4. This point is 0, negative 1. And this point is 0, negative 3. What do these all have in common? Well, they all have a 0 as the x value. What do they all have in common? X equals 0. Okay? These 3 points, they all intercept the x-axis, and so therefore these are all x-intercepts. Let's see what they all have in common. This point is left 3, up 0, so negative 3, 0. This is 0, 0. And that point is over 2, up 0. What do these points all have in common? Well, in all of them, the y-coordinate is 0. So we should be able to come to some conclusions about y-intercepts and x-intercepts. Here's the summary. The y-intercept is the point at which the line crosses the y-axis. The y-intercept can also be found by substituting a value of 0 for x in the equation, then solving for the value of y. So let's do an example of this really quick. If I wanted to actually, sorry, let me keep it like this. This says find the y-intercept of this graph. So if I know that y-intercepts always happen when x equals 0, I know that the y-intercept will be at x equals 0. Because every single y-intercept that I've seen is in the form 0, comma, something. So that means if I substitute x equals 0, I should get the y-intercept. So I'm going to substitute 0 in for x and solve. And so the y-intercept would be 0, 4, which makes sense because we said in the equation that this is the y-intercept, and that's y. The x-intercept is similar. The x-intercept is the point at which the line crosses the x-axis. The x-intercept can also be found by substituting a value of 0 in for y in the equation of a line, and then solving for the value of x. So like we saw up here, right? X-intercepts were always in the form something comma 0. That's what it meant to be an x-intercept. So x-intercepts happen at y equal to 0. So I substitute 0 in for y, and I solve. Subtract 4 on both sides. Negative 4 equals 2x. Divide by 2. Negative 2 equals x. And so the x-intercept is negative 2, 0. Let's do a couple more examples of this. Example number 1. I'm going to graph this using slope-intercept form and then using x and y-intercepts. So using slope-intercept form, y equals mx plus b. This is my slope, and this is my y-intercept. So from the previous page, the first thing is I identify these. Now I graph my y-intercept, which is at 0, 2. Then I count my slope. Down 2, right 5. Down 2, right 5. Down 2, right 5. Now go ahead and draw my line to represent all solutions, because I only have 3 drawn here. Now instead of using slope-intercept form, I'm going to find the x and y-intercepts and solve. So first, if I'm solving for an x-intercepts happen when y equals 0, because all x-intercepts look like this, right? Something comma 0. Okay, so I'm going to substitute 0 in for y. And then I'm going to solve for x. Now the way to do this is your first move is you actually still need to subtract the constant, because we got to get the variable by itself. Negative 2 equals negative 2/5 x. There's a couple ways for you to do this. However, what I want to do is I want to get rid of the 5. So I'm going to multiply both sides by 5. This becomes negative 10 equals negative 2x. Divide both sides by negative 2. Negative divided by negative is a positive. 10 divided by 2 is 5. So my x-intercept is 5, 0. My y-intercept, that happens at x equals 0, because every y-intercept is in the form 0, comma something. So I'm going to substitute 0 in for x and solve. So if I want to graph this using x and y-intercepts, here's my x-intercept, 5, 0. Here's my y-intercept, 0, 2. And then I draw my line. These two graphs look exactly the same, which is why it's okay to use either one of them when graphing the line. For the your turn, I'm actually just going to do this, since I think we can do this one on our own. So let me first solve for the x-intercept. X-intercepts happen when y equals 0, because all x-intercepts are in the form something comma 0. Substitute 0 in for y. Much like the last one, I actually still need to move the constant first. So this becomes 4 equals 4/3 x. I'm going to get rid of the 3 in the denominator, so I'll multiply by 3 on both sides. 12 equals 4x. Lastly, divide by 4. 3 equals x. So my x-intercept is 3, 0. Let me go ahead and graph that. Great. Now my y-intercept is at x equals 0 because all y-intercepts are in the form 0 comma something.